Welcome back to section 932. We're still talking about solving these polynomial equations. So for number 7, to look at our possible solutions, the factors of the leading coefficient, the constant, over the factors of the leading coefficient. So it's going to be the factors of 4. So plus or minus 1, plus or minus 2, plus or minus 4, over the factors leading coefficient plus or minus 1. So our possibles are just the 1, 2, and 4. Now, once again, graph this polynomial, please. And make sure you pause. And then when you do that, the graph. So from the graph, I see 3 x-intercepts. I see that x equals 1. I see x equals 2, and I see x equals negative 2. Doesn't matter which one I start off with. I'm going to start with the 1 because I feel like it. Now, with your synthetic division, be careful. Our coefficient for x to the 5th is 1. There's no x to the 4th, so we need a 0. X cubed is a negative 4. X squared is a negative 1. X to the 1st, we need a 0. And our constant, we need the 4. Bring down the 1. 1 times 1 is 1. Add, you get a 1. Multiply, you get a 1. Add, you get a negative 3. Multiply, you get a negative 3. Add, you get a negative 4. Multiply, you get a negative 4. When you add, you get a negative 4. Multiply, you get a negative 4. And the remainder is 0, which is good. So we got a lot going on here. So our factors, g of x is, so the factor when x equals 1, it's x minus 1. This was x to the 5th, so x to the 4th at the bottom. So x to the 4th plus x cubed minus 3x squared minus 4x minus 4. And we can keep going. Now I'm going to divide by the 2. Now we don't use our original polynomial, we use the 1 right above. 1, 1, negative 3, negative 4, negative 4. Bring down the 1, 2 times 1 is 2. Add, you get a 3. 2 times 3 is 6. Add, you get a 3. 2 times 3 is 6. Add, you get a 2. 2 times 2 is 4. When you add, you get a remainder of 0. Still good. So now, g of x equals our original factor, x minus 1. And our new factor, when x equals 2, it's x minus 2. And from our synthetic division, that's our coefficient for x cubed. So it's going to be x cubed plus 3x squared plus 3x plus 2. And now for my last x-intercept, the negative 2. You could do it in any order. Your just intermediate steps are going to be a little different. But everything in the end is going to be the same. So bring down from right above 1, 3, 3, 2. Bring down the 1. Negative 2 times 1 is negative 2. When you add, you get a 1. Negative 2 times 1 is negative 2. Add, you get a 1. Negative 2 times 1 is negative 2. Our remainder is 0, which is good. So g of x equals our factors, x minus 1, x minus 2. When x equals negative 2, that's going to become x minus negative 2, which is x plus 2. And then this is x squared. So it's going to be times x squared plus x plus 1. Now I can tell that x squared plus x plus 1 is not factorable right away. So now this is completely factored. But we need to find the 0. So set each factor equal to 0. X minus 1 equals 0. X minus 2 equals 0. X plus 2 equals 0. And x squared plus x plus 1 equals 0. Now, we got our solutions already. We found these just by looking at the graph. X equals 1, x equals 2, x equals negative 2. And now, since this quadratic is not factorable, we can use the quadratic formula. X equals the opposite of b plus or minus the square root b squared minus 4ac, all divided by 2a. So x equals negative 1 plus or minus the square root 1 squared minus 4 times 1 times 1, all divided by 2 times 1. So x equals negative 1 plus or minus the square root of negative 3, all divided by 2. Now the square root of negative 3 is the square root of negative 1 and the square root of 3. So it's I root 3. So it equals negative 1 plus or minus I root 3 all divided by 2. So when we split them up, x equals negative 1/2 plus or minus I root 3 over 2. There's our other two solutions, and they're complex solutions. You'll see when you look at the graph, it doesn't cross the x-axis at those points. It only crosses at 3, not at 5. So our zeros, x equals 1, x equals 2, x equals negative 2, and then x equals negative 1/2 minus I root 3 over 2, and x equals negative 1/2 plus I root 3 over 2. There's our 5 zeros. 3 of them are real, and 2 of them are complex. All right, let's go to the next page then, please. Number 8. Once again, our possibles, the constant over the leading coefficient. So it's going to be the factors of 9 plus or minus 1, plus or minus 3, plus or minus 9, over the leading coefficient plus or minus 1. So it's just going to be those 3 possibles. From the graph, so take a moment and graph it. So from the graph, I see that x equals negative 1. You only see that one x-intercept. So negative 1 goes on the outside, and on the inside, 1, 2, 10, 18, and 9. Bring down the 1, multiply, you get a negative 1, add, you get a 1. Multiply by negative 1, you get a negative 1, 9. Negative 1 times 9 is negative 9. Add, you get a 9. Multiply, you get a negative 9, and our remainder is 0. That's what we want. So when we start factoring this, p of x equals x minus negative 1 becomes x plus 1. And this was x to the 4, so here we have our x cubed. So it's times x cubed plus x squared plus 9x plus 9. Now, I want to keep factoring this, but I only see the one x-intercept. Look at the graph again. Do you see how it bounces off the x-axis at negative 1? That means it's repeated. It's repeated twice. So I can use my negative 1 again because of that. Now negative 1 goes on the outside and from above. 1, 1, 9, 9. Bring down the 1. Negative 1 times 1 is negative 1. We add, we get a 0. Negative 1 times 0 is 0. Add, you get a 9. Negative 1 times 9 is negative 9. Add, you get a 0. That's good. So our factors, p of x equals x plus 1. And then again, another x plus 1. And now it's x squared plus 9. Now, p of x equals, so we have x plus 1 times x plus 1. That's x plus 1 squared. And I can actually factor x squared plus 9. Actually, I can't factor, excuse me. We can't factor that. So x squared plus 9. That's as factored as it's going to get. Because if I do b squared minus 4ac, I get 0 squared because my middle term is 0, minus 4 times a, which is 1, times 9. So I get 0 minus 36. Negative 36 is not a perfect square. So now to solve, set the factors equal to 0. X plus 1 equals 0. X squared plus 9 equals 0. X equals negative 1. That's being repeated twice. We knew that from the graph. And now x squared, subtract 9 from both sides. X squared equals negative 9. Take the square root. X equals plus or minus square root of negative 9, square root of negative 1, square root of 9. It's going to be plus or minus 3i. So our solutions, x equals negative 1, x equals negative 3i, and x equals positive 3i. You can see it only has one x-intercept, but since it bounces, we have 2 real solutions and then 2 complex, 2 imaginary solutions. Let's do one more. Number 9. Once again, Our possibles, the leading constant over the leading coefficient. So the factors of 5 are plus or minus 1, plus or minus 5. And our leading coefficient plus or minus 1. So here's our possibles, 1 and 5. So from the graph, I can see that x equals 1 and x equals 5. Those are my two x-intercepts. I'll do my 1 first. It doesn't matter which one you do first. So then on the inside, 1, negative 8, 18, negative 16, and 5. Bring down the 1. 1 times 1 is 1. Add, you get a negative 7. 1 times negative 7 is negative 7. You add, you get an 11. 1 times 11 is 11. Add, you get a negative 5. Times 1 is negative 5. The remainder is 0. That's good. So our factors, d of x equals, when x equals 1, our factor is x minus 1. This was x to the 4, so x cubed minus 7x squared plus 11x minus 5. Now, we use the 5 next. 5 goes on the outside. So we have our 1, our negative 7, our 11, and our negative 5. Bring down the 1. 5 times 1 is 5. Add, you get a negative 2. Multiply, you get a negative 10. Add, you get a 1. Multiply, you get a 5. The remainder is 0. That's good. So we have our factors. We have x minus 1. When x equals 5, that's going to be x minus 5. And then x squared minus 2x plus 1. And we can keep factoring it. D of x equals x minus 1. And now we have our factors of this. It's x minus 1 times x minus 1. Now if we rewrite this, d of x equals, it's x minus 1 cubed times x minus 5. That's fully factored. That's fully factored. And our zeros, our roots, x minus 1 equals 0, x minus 5 equals 0, x equals 1, and x equals 5. We only have two distinct zeros, two distinct roots. Because if you look at the graph, what happens is the graph doesn't go directly through the 1. It kind of curves through it and then back up again. That's repeated 3 times. That's where we're seeing that repeated root 3 times. Okay. I will see you again in the next part. We're going to talk about factoring different types of polynomials as well. Thank you and have a nice day.